Okay, let's take a look at isotonic solutions. We have a problem here, but before we go into this problem, I want to say one or two things. Isotonic solutions are solutions, products that are prepared in such a way that they have the same tonicity with the body fluids. You know, whenever a solid substance is dissolved to make a solution, that product is capable of exerting some level of pressure we call osmotic pressure. And the mucous membrane, because of this pressure, there's tendencies for irritation to occur, or you can even get to the extent of cell destruction. And most of the products instill in the eyes, in the nose, and some other part of the body are supposed to be isoosmotic and isotonic with the body fluids. And for us to achieve that, some other substances need to be added to be able to make a particular preparation isotonic. Now, the normal physiologic fluid we call normal saline is made up of sodium chloride, and it has been discovered that sodium chloride 0.9% weight per volume of sodium chloride has the same, that is isoosmotic with the body fluid. Now, sodium chloride is normally added. It has also been discovered that the normal body fluid depresses the freezing point of water by 0.52 degrees Celsius, that is minus 0.52 degrees Celsius. And any solution that can depress the freezing point of water to the same 0.52 degrees Celsius is believed to be what? Isotonic. Now, 0.9% weight per volume sodium chloride has been able to achieve that. It depresses the freezing point of water to 0.52 degrees Celsius. Now, everything we are doing in terms of preparation of isotonic solution is to ensure that we make that solution to be able to depress the freezing point of water to that level. So we'll keep certain proportions until we achieve that. Now let's look at these questions. By the time we are done with this question, we'll be able to understand what isotonic solutions are. Let's see what we have here. An IV solution of sodium chloride 0.2% needs to be made isotonic by addition of anhydrous glucose. What weight of anhydrous glucose is required in the preparation of 1 liter of the IV solution? Is another way of asking you what weight of this anhydrous glucose is required to make 1 liter of this IV solution. What? isotonic. We are given the following. A 1% solution of sodium chloride depresses the freezing point of water by 0.576 degrees Celsius. A 1% solution of anhydrous glucose depresses the freezing point of water by 0.1037 degrees Celsius. Now let's go. Take a look at this question again. The first thing we need to do is this. Let us find the extent to which 0.2% of the IV solution of sodium chloride on its own can depress freezing point of water. Let's go. We are given already that 1% of sodium 1% of sodium chloride solution depresses the freezing point of water by what? 0.576 degrees Celsius. Okay. Now, 1% weight per volume of what? Sodium chloride what? Solution depresses the freezing point of water by what? 0.576 degrees Celsius. Now let's see the extent to which 0.2% weight per volume of sodium chloride can depress it. Okay. 0.2% weight per volume sodium chloride can depress it to what extent? We don't know. We call it X. So X is now equal to what? 0.2% weight per volume times what? 0.576 degrees Celsius. All over what? 1% weight per what? Volume. 1% weight per volume will cancel percent weight per volume. So 0.2 times 0.576. Let's see what we have. 0.2 times 0. So X is under what? X can also be written in this form. 2 over 10 times what? 0.576 degree what? Celsius. 2 over what? 10. So if we multiply this by 2, we divide it by 10. So let's see. This will now be what? 2 times 6. We have 12. 12, remember what? 1. We put 2, carry 1, put here. 2 times 7. We have 14. 2 times 7 is 14. 14 plus that 1 is what? 15. We put 5. Carry 1 again, put here. 2 times 5 is 10. 2 times 5 is what? 10. 10 plus 1 is what? 11. We write 1 here. We write 1 here. Carry 1, put here. Point will come up. 2 times 0, 0. Plus 1 becomes 1. So we have 1.152 over what? 10. So this divided by 10 will give us what? 0.1152 degree what? Celsius. Okay. So that means X is now equal to what? 0.11 what? 52 degrees what? Celsius. Now, this X, this 0.1152 degrees Celsius is the extent to which 0.2% of sodium chloride can depress what? The freezing point of water. So this depression alone is not enough for it to be isotonic. For this to be isotonic, that means it needs to depress the freezing point of water to what? 0.52. 0.52 degrees Celsius. So how do we achieve that? First of all, let's find what is remaining. So we get the difference between 0.52 degrees Celsius and this 0.1152. From there, we then having determined the difference. The difference now is what is remaining to be depressed further for it to be what? Isotonic. Now let's go. So let's find the what? The difference. The difference is now equal to what? 0.5 0.52 degrees Celsius minus what? 0.1152 degrees what? Celsius. So let's go. 0.52 minus what? 0.1152. So we can add up 0 here. Now let's go. Take one from here, put here, it becomes what? 10. Then borrow 1 here, put 2 here, it becomes what again? 10. 10 minus 2 is what? 8. What is remaining here is 9. 9 minus 5 is what? 4. What is remaining here is 1, because we took 1 from here ab initio. So 1 minus 1 is what? 0. What is remaining here? Still 5. Nothing was taken from here. 5 minus 1 is what? 4.0 degree what? Celsius. We've gotten 0.4048 degrees Celsius as the further depression that is needed to get to the 0.5 2 degrees Celsius, which is the freezing point depression that is caused by normal body fluid. And this is what we need to depress this solution to make it what? Isotonic. Now let us now go back to the question and now determine the concentration of anhydrous glucose that can cause this depression. Now we have already established, it is already given to us that 1% weight per volume glucose cause depression of what? 0.103 what? 7 degrees Celsius. So now, what we want to know the strength of this glucose that can cause this 0.408 degrees Celsius depression. 0.4048 degree what? Celsius. We don't know, we call it what? X. So X is now equal to what? 1% weight per volume glucose. Sorry, let me cancel the glucose. What weight per volume times what? 0.4048 degrees Celsius. All over what? 0.137 degree what? Celsius. So that means degree Celsius cancels the degree Celsius. That means X is now equal to what? This time this is 0.4048% weight per volume. All over what? 0.013 what? 7. So if this divide this should give us something like this. This can only appear 3 times here. It can only appear 3 times. And so we have our 3 points. What? So let's multiply this by 3. If you multiply this by 3, 1037 by 3, we're getting something like this. 21. Carry 2 put here. Put 1 here. 3 times 3 is 9 plus 1, 11. Carry 1 put here. 3 times 0 is 0 plus 1, 1. 3 times 1, 3 is what? 3. And if you subtract this 311 from 40, because this point has already shown us that this can cancel this. Because if you put it in their place values, 1000 will cancel 1000. So it's as good as this cancelling this. So we are working with 4048 and divided by what? 1037. So now here will now be what? 311. If you subtract 4048, 311 from 4048, we get something like this. This is 7. 4 minus 1, this is 3. Carry 1 put here, 10. 10 minus 1 is 9. How many is remaining? 1. So 397. So now, for this to divide this, you have to put 0 here. And if you put 0 here, you now do what? Add another 0 here. So this divide this will give us, inside this now, we can only get this thing 9 times. So this, you can get this what? Sorry. Sorry, you can't put another. There's already points here, so you don't put another 0. You are for you to put this 0, you have already added points here. So this point has taken care of this 0. So now this divide this, you can get it only 9 times. So if you multiply this by 9, if you multiply this by 9, you can be getting something like this: 7 times 9. 9 times 7 is 63. Carry 6, put here. 9 times 3 is 27. Plus 6 is 33. Carry 3, put here. 9 times 0 is 9. Plus 3 is 3. 9 times 9 is what? 9. So as you can see, you can go what? 9 times. 9 3 70 minus 9 3 3. Carry 1, put here. 10 minus 3 is 7. 1 has already left here, making it 6. 6 minus 3 is what? 3. 9 3 can 2. So we have 9 remainder what? 37. We have 9 remainder what? 37. So for us to divide again, you add 0 here. Once you add 0 here, you cannot add 0 again, making it 3007. 3007 divided by this. This can go into this 3 times. 3 times. So 3 times 1037. 3 times 7 is 21. Carry to put here. 3 times 3 is 9, 11. Carry 1, put here. 3 times 0 is 3, 1. 3 times 6 is the same 311. The same what? 311. So if you remove 311 from here, 311 from here, carry 1, put here, 10 minus 1 is 9. 9 minus 1 is 8. 6 minus 1 is 5. You have 5, 8, 5, 8, 9. With 5, 8, 9, what will happen next is that this divide this, add 0 here. If you add 0 here, this will now be what? Can go this way, these things 5 times. So it will continue. So we've gotten 390. Let me clean this place. So we've gotten 39035. 39035% what? Weight per what? Volume. So this is the concentration of the anhydrous glucose that can cause 0.2%. Sorry, that can make 0.2% sodium chloride solution what? Isotonic. But inside this 0.2%, remember that 0.2% is the same thing as what? 0.2 gram over in 100 what? Ml. So what it implies is that this 39035% weight per what? Volume is the same thing as what? Remember, 3.9035 gram over in what? 100 what? Ml of what? Anhydrous glucose what? Solution. This means 3.9035 gram of anhydrous glucose in 100 ml solution. Now, take a look at this again. This thing can only cost 100 ml, can only take care of 100 ml solution of sodium chloride what? 0.2% sodium chloride what? Solution. So if 3.905, if 3.903 gram, I'm coming. So if 3.9035 gram of what? Glucose costs 100 ml. Sorry, if it's 3.9035 gram of glucose, anhydrous glucose makes 100 ml of sodium chloride what? Isotonic. So how many gram of this can make 1,000 ml? Because 1 liter is 1,000 ml. 1,000 ml of sodium chloride what? Isotonic. We don't know, we call it X. So X is now equal to what? 3.9035 gram times what? 1,000 ml. All over what? 100 what? Ml. 100 divided 1,000, you get 10. So this is now equal to what? 39.03 what? 5 gram. Approximately what? 39.0 what? 3 gram. So 39.03 gram. 39.03 gram of 39.003 gram of anhydrous glucose is required to make this preparation of 1 liter of the IV solution isotonic.
Admission. 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 Dear ladies and gentlemen, I bring good news. Admission into the diocese on the Niger School of Pharmacy Technician EENU Mission Hospital is on. The School of Pharmacy Technician (PhD) is an accredited tertiary institution that offers students a diploma degree to work in hospitals and pharmaceutical companies in order to promote safe and effective use of medicines at grassroots level. Graduates of Pharmacy Technician School EENU who wish to study pharmacy in the university can obtain direct entry into any university of their choice. The school has a well-equipped laboratory, comfortable hostel, and a healthy refectory. The requirements for admission are credit in English, mathematics, biology, chemistry and physics. In GCE, WAEC, NECO, NABTEB are not more than 2 sittings. The School of Pharmacy Technician (PhD) is located at EENU Mission Hospital, Agidi, Anambra State. For more information, call 0803 708 1512, 0813 868 2003, 0803 267 5322. Diocese on the Niger School of Pharmacy Technician. A tradition of excellence.